Thank you for coming. So I wanted to begin by just professing that this is about as much of talking about my dirty laundry as I've ever done in a presentation. So hopefully you like hearing about dirty laundry. I basically wanted to present on a problem that I constantly struggle with and how I'm trying to address it. And I use Python as part of the solution. It's not the totality of it, but that seemed like the thing to be emphasizing here. And I have a couple of example scripts that are fairly basic, but as with a lot of the projects that I've heard about and am working on myself, I feel like the to-do list for this project is much bigger than the done list. But I hope that you are, by virtue of being here, I hope to sort of raise the flag and see who came, because hopefully that means you are also interested in these kinds of problems, and maybe even can tell me simpler solutions than the ones I'm working on. So the problem statement that I framed for this is that I think there are fantastic resources to support writing reusable code at the line level, great resources for software level organization, and it just went to a different talk on that in the last session. And then more and more of these fantastic specifications for project level concerns, things like reproducibility, file path management, et cetera. But what I don't see a lot of is things that step up the folder tree to the level of the system or your computer, or even like maintaining your various projects on more than one computer. And I don't even know what that's called. I don't know what the name for that is. I know what a project is. I know what a script is, but I don't know what that macro level is called. And so I invented a name for it called Code-Scape, and that's in my title, which I'll get to in a second. But a big thing underpinning all of this is this fear and anxiety about losing things. And I don't know if any of these things have ever happened to you, but if you have a hard drive fail, if you've ever been hacked, yes and yes for me. If you've ever been not able to find a file you know exists, or if you've forgotten something exists and then remembered right after you redo it, yes and yes for me. If you've ever accidentally deleted something or overwritten it and realized you don't have it backed up, yes, I've done that. If you've ever lost something because you didn't save it as you went and your computer crashed, or you went to hit submit on a web form and you got a 404 error and everything that was in that field that you were typing is now gone. Or if you've ever, this is rare, but it has happened to me, if you've ever uploaded something to a cloud platform and then you lost access to it, or that platform went defunct or something, that's another way to lose a file. And a lot of these can just be mitigated by things like backing it up, right? But once you get to a certain size and level of complexity, backup becomes a full-time job. And a lot of us have a system administrator who does those tasks. But if you're working somewhere in an in-between space where you have certain things that are being backed up and certain things that aren't, it presents this whole set of problems. This talk could have the subtitle, if you can't hire a sysadmin, how do you maintain and organize your Code-Scape? What I've proposed here is what I call, I hope, a better umbrella, a well-tended garden, and then some Python, basically. And what I mean by this is, if you think of organizing your files and folders, maintaining your code, this whole thing about like building a second brain that you hear a lot about now, automated backups, file synchronization, version control. What if you think of all of that as one big thing? And you can call it codebase, you can call it something else. I don't really care. I couldn't think of, call it, Code-Scape. I just couldn't think of a better word that wasn't also allocated to some other meaning, like codebase, that typically describes like one piece of software or something. And then how do you kind of set things up so that they're really maintainable and organized? And then how can you use automations, preferably with Python, to help keep the code organized, searchable, and safeguarded? So I mentioned some of these before, but like, if you haven't heard of the search sort trade-off, what I encounter on a pretty much daily basis is the ethos that organizing things is a waste of time because search just gets better and better. So just dump it all in one folder, right? And this is impractical for various reasons, but at a certain scale, just reading through all of the files in one directory becomes a non-trivial, expensive operation. And you know, there's lots of limits to searchability. And then if you do have to go in and browse, the emotional weight of doing this when you're not well organized is actually very high, and it can cost a lot of time. So that I think it is a trade-off, search versus sort, but I don't think the best answer for all use cases is no sorting. I think there's a balance there for most people. I could talk about more of these things, but you'll see me refer to them later. And I'll just emphasize the word Code-Scape is made up, and it's just for convenience. So forgive me for inventing a word. So why Python and not just a bunch of like, I think it's more common to do all this with like bash scripting, typically. And you can do a bunch of, you know, bash files. And I think you can do that, and a lot of people do that. And the tools that I'm typically using here are, you know, rsync and git and a bunch of things that are command line available. But there are other tools as well. And what I like about Python is you can, it is the Swiss Army knife programming language. You know, it has all those different blades you can flip out. And it's a nice controller for the orchestration, one layer above all those utilities that you would use. And then the way I use it is, you'll see my scripts in a Jupyter notebook. They're using JupiText. And there's lots of interventions where I'm running something, and then I look at the output and I decide what to do next, meaning human intervention or in the loop. And a lot of these bash scripts, they're more well suited for like, I don't want to look at this at all. I just want to push this button or run it as a cron, and I'm not going to interact with it. I just need to know that every 24 hours I run rsync on these certain files, and or you know, move them to a server or those types of operations. And then you know, because it's a Jupyter notebook, it affords having a kind of descriptive or literate programming basis as well, which is a matter of preference, but it is something that I prefer. So these are some of the particulars of how I do coding, and I know that they're weird because I am a professor. I work at Denison University. It's a small liberal arts college. And so for some of you, like, this might all be decided by your company. But for me, I have a laptop and a research machine. I have various cloud platforms that I either am required to use or I want to use. So at least one of each of those. And then I'm trying to use the ones I want for everything I'm allowed to use it for, and then the ones that I have to use for the things I have to. Maybe that's actually fairly common. Same thing with tooling. But I have some kind of more formal coding projects, especially if I'm publishing an article. That gets its own GitHub repository, and I want to follow kind of best practices for reproducibility there. But then I also have code snippets, and I am embarrassed to say how many of these I have because, you know, ideally it would be like mostly projects with like, you know, 30 to 50 snippets at the most, but it's more like hundreds, right? And some of those are for students, some of those are things I'm learning, some of them are hopefully going to become more formal, but I do have to just deal with that reality. And I do have just a lot of larger sets of data, the biggest being like something like 8 terabytes of data that's sitting on an external hard drive that I'm sometimes moving pieces of it onto my computer and off to work with it. So I'm guessing there's somebody here with even bigger data and maybe just only connecting to like a data store or something, I don't know, but you just want something that kind of works for large files and like more complex, highly nested data on the disk, as well as storage, retrieval, and reuse of code, and then some automation. That's what I'm going for. And so my ecosystem looks kind of like this. Computer one, it doesn't really matter for the visual, but like, say it's your laptop. You've got these projects. You might have like a repository you're actually pushing to. You might have a fork. You might have a read-only. You want to be able to differentiate between those or among them. You have a coding sandbox with more files in it than it should have. And then you have like lots of other support files that don't belong in a project or your sandbox, but they're actually vital to the non-code portions of the same ideas, right? So you wouldn't want to fill up your coding project with like, because I'm a professor, the other materials for my classes, right? The readings. Those don't really belong in the GitHub repo. I don't know for you what would be analogous to this, but I'm guessing you have lots of files that are pertinent. Maybe it's bigger PDFs of documentation, maybe it's how-tos, those types of support materials that really don't belong in the repository. So I've got projects that I'm syncing on a case-by-case basis to GitHub. I've got my sandbox, which I want to both sync to like, say, Google Drive in the cloud, and then also to have some version of that on GitHub for version control. And then other files are really only syncing through Google Drive. They're not being run through GitHub. And then I also have external disks, but like a lot of you, I have so much data and so many files, there is no external hard drive that fits everything. So I would love to just have it all on one drive and just, time machine the whole thing. But I'm just at a scale there where I cannot do that, and I'm guessing some of you are too. So, okay. So what I want to be able to do here is specify a folder tree where I have like a folder for research-related things, and then each topic is in a folder. Teaching-related things, course, semester, assignment, down like that. But then, as things get more formalized, ideally, the topic folder under research gets moved to its own repo. And so I have a folder structure where I have a parent folder called repos, and then the exact same structure down. So it's repos research topic, repos teaching, course semester, and then in that semester assignments, right? And that becomes its own GitHub repo eventually. But while I'm working on all the more like in progress versions of that course, I want to be doing Git commits and having version control and things like that. And then, a kind of catch-all of utilities. So I know this is really specific to me, but my sense is that a lot of you would have some kind of sandbox becomes a project, and then when it's done, needs to be archived setup, something like that. That seems to be a common element here. And then things that are more specific to a project and things that are more macro, and they're like a utility that I run for all of my projects or something. So that is, that's what works for me, basically. But in specifying all this out, I think it makes it easier to automate as well. This is just my first Python example, and it's really straightforward. I actually pulled this off of Stack Overflow, this particular function, and it's part of like a group of more functions that I run, but I wanted to highlight it. The slide doesn't show the actual code, it just shows the docstring. I will pull it up in a Jupyter notebook in a second. But basically, once you've got this structure, the idea is to be able to iterate through the structure and compare folder by folder at various levels, whether the folders are equal. Now you could say to yourself, well, why not just actually do rsync, and you don't need to test whether they're equivalent before you do that, because rsync will solve that. Well, for me, figuring out if things are needing to be synchronized is basically part of the determination of whether I want to run rsync, right? And so there's different layers, and so it's like, I'm going to do a very fast, are these definitely not in sync anymore? And then if there's no detected, they're not in sync, I'm going to do a deeper check, right? Because the cost of doing the synchronization is actually sometimes very high, and it takes a very long time, depending, right? rsync is pretty good at speeding things up the second time you do it. But these are, that's the idea of this utility. And if I can do this, I'll just, apparently I have 1 second to get to the green button before it goes away. So this is the compare and sync. And the actual script here that I'm running rsync with like the dry run flag, so it won't actually do the delete uh, and sync here. It'll just dry run it. But I'm just, this is, like I said, it's super simple, but it's just doing like rsync with flags, the delete flag, and then, you know, this is all in a GitHub repo, and I have a test source and a test target folder that I'm running that on. But this would work with like local to external disk, for example. And so the idea of this is very straightforward, but you might say, okay, these folders are big enough that I'm actually gonna like navigate down the tree and do this pairwise to the subfolders, for example, right? There's lots of potential to kind of like divide and conquer that type of a script. My second one, I think I can do this without going back to the slides. This is like another example where the goal is to recursively walk down a directory tree and turn that into a JSON representation of what is in that folder and all its subfolders. And this is a little quirky to the way I want to do this, but a big part of this for me is all the way down to when you finally get to a project, I'm trying to never have a file and a folder be siblings with each other. And this may sound weird, but like if you think about it, it makes folder comparisons between two disks easier. Easier to code and also just easier to conceptualize in your own brain. But like, is this a folder that contains files, or is it just a folder that contains more folders? And then once you're down to the level of like a project, you kind of can't do that anymore, right? But the idea is to actually specify that you've reached a project level and you don't have to apply that. But this one will, it'll just make the tree, and then this is a little counterintuitive too, but like the demo that I did, it actually like flattens out the tree so that you can do Panda stuff on it too. So, you know, you want that hierarchical structure for certain things like visualization, and then there might be assessments of like disk usage that you want to perform just by like looking at a data frame. And so this is a really simple structure with like a source, an A, a C, A, B, C, and D, and then the source is at the top, so it has no parent, and then A's parent is test source, C is A, D is C, B is A, and that's the same instructions for the tree that you would have in the hierarchical structure. And then what this sort of builds up to is the ability to, again, I'm more interested in being able to describe the similarities and differences than I am in just solving and synchronizing, although I also care about that. But in certain situations, I want to be able to perform like non-memory intensive like checks to see if things are synchronized. And one thing that I have, some of this is just fueled by anxiety because when all you do is reorder files into subfolders, a tool like rsync, the way it synchronizes is typically like, it will solve that as a delete operation and a create operation. It doesn't like worry about moving it, right? And so if you are only ever syncing in one direction, this is no problem. But if you are worried that there are files that are on the disk that aren't local, whichever direction in which you go first, if you delete, you could lose, and if you don't delete, you could accidentally create duplicates, and then you need to do deduping. That's the way. There's probably a better solution to this, but it might have more to do with just knowing like which one is the more up-to-date source versus target, and I'm just very nervous about getting that wrong and messing things up. So I'm often doing these checks to make sure the source and the target are what I think they are. And this last one is a script. Again, these are just sort of like the kinds of things that this setup affords. But because I have a repos directory, and then in there I also have like repos that I want to ignore, but in my repos directory, I can basically run an automation where I collect which of the subfolders of the repos directory are actually navigate down recursively, figure out which ones are top level of a repository, and then build up a list of which ones are repository. And then I'm sure there are lots of reasons why you wouldn't want to do this, but there are situations where you do, which is basically iterate through like, say, 20 repositories and just pass the git pull command and then git add, git commit, and git push to every single one of those repositories. So for these like repositories that represent like one of my classes, that's safe for me to do because I'm the only person who's pushing to that. So when I'm executing this push-pull, all I'm doing is synchronizing my laptop with my research machine through GitHub, basically. But you know, I thought it was kind of a cool example of like where if you're sort of putting these tools together, you could you know, have like this sandbox that is up to date on one computer and not the other, and then I've pushed it, so now I can pull it, and then I can run like a get status through just a little function, again, that's just calling subprocess. My branch is up to date, so I don't really need to do this, right? And I could still run the pull push command because since it's up to date, it won't do anything bad. It'll just be like if you did a git push, but there was nothing to push. But if this was some, I don't know, okay, here's a great example of why I do it this way. If I accidentally put a giant file in that repo, this is where I would notice it and not do that push, right? Oh, I've added this giant you know, word embeddings file and I didn't add it to the git ignore. I'll catch it here, basically. So those are the example scripts. And they're here as well. The link to my GitHub. This is pretty minimal now, but I'm gonna keep pushing to it as I go. And I have a bunch of things I want to do more with. So I have a function that I didn't share because it's not really ready to be shared. That basically just walks down that structure and identifies any folder where there's a folder and a file next to each other as siblings. I go through and remove those as a matter of habit, but I constantly break my own rule accidentally when I'm trying to save time. And so I basically just have a script that I use to try to keep myself honest. I have a bunch of things where I use the GitHub API to basically, one of the things I do every year is move repos from one organization to an archive organization so that the org doesn't get filled up with student repos. And I'm using GitHub Classroom, so my students are constantly creating forks that live in my org repo. Doing analysis of output and error messages, and then using these to build data visualizations that represent the state of the synchronization, for example. And then some things that I want to do, they're kind of next on my list, are listed here. But like I said, there's just a bunch more that I want to keep adding here. But one of the things, and I think this applies to the like reproducibility level as well, is hooking up to like a best practices for representing the files that have been omitted. This would apply to like a GitHub repository where the data is not there because it can't be shared, right? And there are ways of doing this. But then it would apply to like this version of this folder that is copied over to this external drive has everything but the data set because that data set is too big for that drive, right? So when you start getting into situations like that, you want like, I don't know, it's probably something like a YAML or a TOML that actually describes those data and where they are stored for you on your system, on like some external drive or some cloud. And there's a bunch more here, but I do want to stop there so that there could be at least a little time for questions and comments. Because, and I'll gladly stay after as well, but I have a lot of questions for you too. So I will officially end there and say thank you. Thank you very much for coming to my talk. And we have 5 minutes left, but like I said, I'm happy to stay after too. Yes? Oh, sure. Do you want it to be recorded? I am not aware of it, so I would love to hear about it. The question was about a tool called, what is it, Git Annex? A-N-N-E-X? Yeah, Git Annex as a tool. Is anybody using that? So I'll write it down, but I don't know anything about it. Yes, please. Yes. So the deduping stuff that I have is, not what I want it to be, but I'm using a lot of the stuff that I think a lot of people are already using, which is like command line, like hash comparison for deduping. But the thing that I really would like to have more of is like this complexity of like having the same thing in two different places in the tree. That's what I worry about, like both having a lot of duplication and then I also worry about accidentally deleting something that isn't an actual duplicate. But one of the reasons this is tough for me, at least the challenge that I run into is I often want, within a project, I want to name a file the same thing for reasons of reusable code. So I like to have a folder called utils, for example, and I like to have utils.py. And I think a lot of people do stuff like that, right? But then you do searches on the desktop and you find 17 different files called readme, and it's like, and I was talking about this with somebody yesterday, but like, you don't want to have to like create an Elasticsearch of your own files and like do a search engine to find your code, but like you also, what is it that's like in between that level of complexity and prior work, but is more than just like all the kind of dumb system searches that we do when we're like either using the Finder or using the command line to look for like matching file names, right? So if people are using tools they like for that, that is another thing I would just love to, like, it just feels like there should be a drop-in solution that lets you do fairly light indexing and searching across your like .py files or your Jupyter notebooks for keywords inside of the notebook, right? And it shouldn't require something as, Elasticsearch isn't like the hardest thing in the world. I'm not trying to complain. It almost seems like there should be like a one-click tool that you just specify which folder you want, and it sort of pulls up a local host search box, basically. But yeah. Eddie. Yeah, because right now what I'm doing is like, it's, a reminder on my calendar, and then I pull up the Jupyter notebooks. It still saves me a huge amount of time. But right, like if you want to do all the ones that don't really require like you to really make any decisions, maybe it would be better to just execute it with like a bash script. And I think people do that and set it up as like a cron. I don't know. Are most of you doing something like that when you run your? And some of you are using software to do this too, right? Like, oh, I just have Time Machine set up at Friday at 5. It, backs up everything to my external disk. Or, I use this. There's like a, bunch of Mac software that does file deduping. It just breaks if you have too many files in the folders. So maybe people are using that because they have lots of folders that aren't like that aren't too big for it. I don't know. Other questions? Yeah. Have I tried Raycast for the Mac? So if you didn't hear that, it's an advanced spotlight search for the Mac. Like, yeah. It just lives up here like this, but it's RECAST. Anybody else using it? Yeah, thank you for the recommendation. I believe we're at time now, but I'm happy to hang around and hear about other tools or hear. Like one thing I ask about on the slide is, what do you wish existed in this space that doesn't? Because you know, one of the nice parts about these conferences is if something we all want doesn't exist, let's make it, right? So thanks again for coming. I really appreciate it. Great feedback, too.